Hello and welcome to the Whippet.net tutorial on pseudocode. Yeah?
Yep.
You excited about this one?
Yep.
Yes. So before we had a discussion about flowcharts, and pseudocode is pretty much the next evolution of that. It's sort of taking logic, whether it's a flowchart or your own, you're sitting there just kind of thinking out a program, and putting it into a structure that's sort of like a language, but not really a language. So that the next movement from there is to take that into real code. So it's kind of a gradient transition where you start with an idea, you move into a flowchart, which puts your idea on paper, you move to pseudocode, which moves it into a computer type realm, and the next step is actually coding it.
So if you haven't seen the flowchart video, we recommend you watch that now.
Actually, just do it.
Yeah.
Just stop right now and go back and watch it 50 times. So generally speaking, and pseudocode is a very high level, informal language, and it's not even a language, it's a set of rules that just describes an algorithm. So like the second point here is very important. It is not a programming language. It is also not standard. The way that Brian and I do our pseudocode is not the same way that company X, Y, and Z do it. It's not the same way that your college may have taught you. It's everyone kind of does it their own way.
The only thing that's common is the basic elements, that there's going to be if statements, there's going to be loops, there's going to be the basic core concepts that we've gone over. You're going to find in there, but how it looks will change from person to person.
We're taking a look at expressions, which we've already sort of talked about, and now we're actually going to start moving into making a real expression. In pseudocode, here's a basic variable expression. On the left side, you have a variable, and on the right side, you have an expression with an equals in the middle. It's no different than any of your basic math equations that you do.
The result of the expression is stored into the variable, just like y equals x plus 1. X plus 1 is the expression, and y is the variable.
So let's take a look at a sample of expressions. Now what Brian and I have set up here are x and y are going to be set to equal numbers. And then what happens after that, Brian?
So x is set as 5, y is set as 10, and it's just like basic algebra. Now the variable z, the result of the expression x plus y, which is 5 plus 10, gets stored as z. So now z is equal to 15. Because x equals 5 is above z equals x plus y, that x has already been stored. So it's a top-down. We're running through a top-down approach. So now a is equal to another expression, but this has parentheses. So whenever you see parentheses, you do that operation first, and then you move outside of it. So first we do z plus x, and then we do z plus y, and then we multiply the result of z plus x times the result of z plus y. It's stored in A.
And expressions in computer programming follow the same rules that you learn in basic algebra.
Yep.
Which is please excuse my dear Aunt Sally, order of operations. Keep that in mind when writing your expressions, because you can get bit if you're not paying attention to this.
The next is introducing the function expression. A function is something that will be called to perform an action. So it's kind of like the expression, all encapsulated into a label. We have the function, what we want to call the function, variables that we pass into the function, and then inside the curly braces is going to be the block of instructions, and then the return statement returns back what the result of this function is.
Exactly. One of the things that we haven't discussed, and now would be a great time, would be the concept of a block of code. And if you look at this function here, there's a start curly brace directly below the word function, and then a close curly brace as the very last character. In the pseudocode that Brian and I use, this indicates a block of code, meaning this code is sectioned off as this. And we will see this when we get into C, and it's going to become extremely relevant. So just as a basic, understand that concept.
Right. So what's between the curly braces belongs to the function that we're referring to.
Right. Exactly.
So now we'll take a look at an example of a function.
Hey, look at this.
So this will be a basic power function.
Sort of like the one that we did in the flowchart. The flowchart example.
Absolutely.
Yeah.
So in this case, just like we described before, we say we're now going to define a function. We're going to call the function power, and we're going to pass the value of x and y.
Does this look familiar to you guys? I hope so.
Between these curly braces is the code that belongs to execute this function. So later on, when we just say power value value, this is what happens inside these curly braces.
And if you notice, we just have a little section that says do power process. Note that, because we will do the power process coming up after we explain a couple other structures. Here's how we call a function in our pseudocode. We just designate the function name and inside of parentheses, we send the list of arguments that we're passing to the function. And when we take a look at this very next slide, here's an implementation of calling the power function that we have created back in the flowchart example, where we set our base equal to 3, our exponent equal to 4. And then answer will equal the power function and the list of arguments, which is base, comma, exponent. And inside of our power function, when we go back a slide, you'll see that we don't call x and y base and exponent, because it doesn't really matter what the variables are named local to this function. The variables have a different name when we're calling it, so it doesn't really matter what the names of the variables are.